All right, so let's look at homework 19, writing polynomial functions from zeros. So they're going to give you these zeros here, and they're going to tell you the degree. And what they're going to want you to do is create this polynomial. And we'll look at this piece last where it says with integer coefficients. So no decimals at the end, or no fractions, excuse me. All right, or decimals. So what we're going to do is we're going to start. Notice they give us 3 zeros. So 1, 2, and then this one right here also gives us the conjugate is a 0. So all you do when you have an I is change it to 5i. So 5i is also a 0. So again, you have 5i, you have negative 5i, and you have 6/5 as your zeros. So what you're going to do is we're going to change the sign to all these, and we're going to write them as factors. So one of them, for the 5i, you write it as 5 minus 5i. For this negative 5i, you're going to write the factor as 5 plus 5i, x plus 5i. And for the 6/5, you're going to write the factor as x minus 6/5. So again, you always change the signs when you're writing them as a factor. All right, and then we have using this linear factorization theorem, it says you could pick some some number as your coefficient. And so this number here, this multiplier, excuse me, we're going to put in whatever number we want such that it gets rid of any of our fractions if we end up with fractions. All right, so what we do is we're going to multiply these first two. So you're going to FOIL this, right? X times x gives us x squared. X times 5i gives us 5xi. Negative 5i times x gives us negative 5xi. So those will cancel. And then negative 5i times 5i will give us negative 25i squared. Remember, I squared is -1. And so that changes it to positive 25. So this piece right here comes from foiling this. And if you want to see me do that, just let me know. And then this piece, we just drop it like it's hot because we don't use it. All right, now we're going to FOIL this again. So all you're doing is multiplying all this out. And this is what we get, right? Because x squared times x cubed, and so forth. All right, so this is what you get. But what we don't want, right, according to the directions, is you don't want a fraction. So see how if we have a common denominator here, it's 5. So what we do is we choose any number for this a. So the reason they choose 5 is so that it could cancel all our fractions. So we distribute that 5, we get 5x to the third. This 5 and this 5 will cancel, so it leaves you with that 6. 5 times 5 is 125. This 5 and this 5 will cancel. It leaves you with that 150. So this is our polynomial here that satisfies all those conditions that were up there. All right, so there's number 1. Let's look at number 2 here. And again, if there's something that you want me to actually write out, just let me know. But I'm walking you through the explanation because sometimes I've been hearing the explanation doesn't make too much sense. All right, so again, we want to write a polynomial with all these conditions. So notice they give us zeros again. So one of your zeros is -4. So again, when you change the sign, it becomes x plus 4. But then you see how this is cubed? People might be like, why is it cubed? Well, notice when it has multiplicity of 3, that's how many copies you have that you're going to multiply. So you have 3 copies. That's what that means. This 1 only has 1 copy. So that's why you have x minus 1 only 1 time. And then it gives us an initial condition. What this right here, what this is going to help you do is this is going to help you solve for that a value. All right, so we'll do that at the end. So always use this piece at the end. All right, so this, you got to do this 3 times. So notice that's what they're doing here. So first they're going to multiply this by itself. So x plus 4 times x plus 4 gives you all this if you FOIL it. And then when you distribute all of this out and you clean up, you combine like terms, this is what you get. Again, if you need help with this, just let me know and I can show you that piece. All right, so this became that piece. Now you got to multiply all of this times this. And I have a video on how to multiply polynomials to make this easier. If you're having a hard time, just let me know. And what it's going to entail, just to show you, there's so many ways of doing this. This x minus 1, you can use a box method. There's all kinds of ways of doing this. And then, so x minus 1, that's this piece right here in red. And then let me make this other piece. I'll do it in purple. I'll put this right here. So I'm going to list all the coefficients. So I got an x cubed. I got 12x squared. I got 48x. And I got 64. And then all I'm going to do is multiply, kind of like multiplication table. So x cubed times x gives me x to the 4th. X cubed times -1, negative x cubed. X times 12x squared, 12x cubed. X times 48x. And this is just like one of the earlier videos, hopefully, that you watched from earlier this semester that I made. X times 64, 64x. -1 times all these, all we do is change all the signs, right? Nothing crazy there. Right? And then we get -64. And so when you combine your like terms, right, all these are like terms. Like term, like term. These two are like terms. These two are like terms. So 12 minus 1, that's what gave you the 11. 38 or 48 minus 12, that's what gave you 36. 64 minus 48, that's what gave you 16. And the -64 is all by itself. So again, that's where this came from multiplying. All right, so the last piece, they tell us now we could use this right here. So notice this is our x value inside here. So they're saying wherever you see x, plug in 0, which is nice because all this is going to disappear except for that -64. So notice they plugged in 0 everywhere. The a stays the same because that's what you're going to solve for. And it should equal f of 0, which is your y value. So it should equal 320. So that's where they got this 320 from. So you have -64, right? A, because everything else canceled out, and all you're left with is A, and the -64, it equals 320 divided by -64, and there you have it. A equals -5. And so now you just plug it in, right? That -5, and then you're going to want to distribute that -5 to everything. And so this is where they get that answer from. All right, just so you could see how those moving pieces work. All right, so that's how you're going to do number 2. Okay, number 3 here. Notice you have this degree, or sorry, this 0. So we're going to change its sign. You have this 0, change its sign, and then you use this at the end. All right, same exact thing. The only difference is that kind of stinks is you have fractions. Don't be afraid of the fractions, right? You multiply them just like any other number. So again, for this example, you had -4/5. You change a sign, you make it +4/5. Why is it squared? Because it has a multiplicity of 2. If this were a 7, you should start crying because this would be a 7 and you have to do it 7 times. All right, this 1/5 had a multiplicity of 1, so you have to have it 1 time. All right, so since this was squared, we went ahead and you had to multiply this out, this out 2 times. And you end up with this right here after you multiply it out 2 times. And then look, you have this fraction. So again, just a reminder, when you're multiplying fractions, think of it like this. Let's pretend, all right? Let's pretend that you were multiplying, let's say it was this fraction times this fraction. So just remember, it's the top number times the top number and the bottom number times the bottom number. So to get this answer that they got right here, they did 8 times -1 is -8, and then 5 times 5 is 25. So again, when you're multiplying fractions, it's really the same thing, except again, top number with top number, bottom number with bottom number. All right, so not that big of a deal. Remember, they combine like terms. So they combine these two together. So -1 plus 8, that's where they got that 7. Then they combine these two together because these are my x values. -8 plus 16 gave us 8, and then over 25. All right. And then so once they got this piece right here, what do? Again, they let 32 equal everything, and they put a 0 here, they put a 0 here, they put a 0 here. All right. So that's what's happening on this next step that I'm about to show you. Okay, so let's scroll down. All right, so notice they put 0 everywhere for x. All this disappears, and you're left with -16 over 125 equals, and they tell you what equals 32. So that's what a 32 equals. So if you want to solve for a, multiply 32 times this 125. Whatever you get, divided by -16, and that's how they get -250. All right, so that -250 goes in the front, and then you just distribute it, right? You'll get some canceling going on, and that's where you have this. All right, so again, don't let fractions mess with you. All right, next problem, what do we have? Number 4. All right, so it's the same ideas, except they're giving you for 3 of those fractions. All right, so here we really have the same thing going on. There's only one tiny difference, is one of the zeros that they give you is a complex number. So 4 minus 5i. So again, whenever you have an I, that always means that you're going to have 2 solutions that are imaginary at least, right? It's going to come with a pair, right? This always comes with its conjugate. So what I mean there is if 4 minus 5i is a 0, that means that 4 plus 5i is also a 0. So that's where this comes in. So here this, you have 2 zeros, and then this is your last 0. But look, it has multiplicity 4. So that means we're going to raise that to the 4th power. All right. So just like I said, you have 4 minus I is a 0. So that means that 4 plus 5i is a 0, right? So that's where that comes from, 4 minus 5i, and then 4 plus 5i. All right, so that's where those two come from, right there and there. Where did this come from? Well, remember, one of our zeros was actually the number 0. So whenever they tell you that 0 is a 0, that means you're just going to have an x, because typically what we did is we do x minus our c, but this time our c is 0. Well, x minus 0, that's just x. That just equals x. So that's where that came from. But multiplicity 4, so that's why you have it raised to the 4th power. All right, so you're going to have to multiply this out right here. So again, I would use my little trick. They do this. I would just do distribute these negatives. Bam. So I would do x minus 4 plus 5i when you distribute. And then I would use my box method again. I like this box, it keeps things cleaner. And then this one will distribute the negative. So you have x, again, -4, and then minus 5i. All right, and then you just multiply. And then we'll combine like terms to get x squared, -4x, you got 5xi, you got -4x, you got 16, you got -20i, you got -5xi, and you got 20i, and then you have -25i squared. But whenever you have an I squared, that just is going to go away, and that's going to change your sign. So this right here is just going to turn into a +25 with no i's. All right, so when you combine your like terms there, you got 16 and 25. That's where they get the 41. This -5i and +5xi, excuse me, these will cancel. You're going to get -4x, -4x. That's -8x. These 20 i's will cancel, and then you have the x squared, right? So that's where this comes in, and that's right here. So now when you distribute that x to the 4th, that's where they get this right here. All right, and again, use that last little piece that they, oh, this time they don't give us the little piece. So here, because I have no fractions, it doesn't even say, yeah, what the lowest leading positive integer expressed. So here, we could just put a 1 for our a because there's no fractions that we need to cancel. So I could just let a equal 1, and if I distribute 1, it doesn't change anything. And here's my answer. All right, cool. So again, get your start early because this homework is going to take a little bit longer, right? You could already see that. And this is just number 19, and we have 20 and 21 this week as well. All right, same thing here, same exact thing. So when we look at our answer key, notice you already have two imaginary numbers, complex numbers. And so this is going to have a pair. So if this is a 0, then we're also going to have negative 5i. And if this is a 0, we're also going to have 3 plus 3i. And so notice we have 1, 2, 3, 4 factors. And so when you multiply it again, this looks confusing if I were to do this, right? That looks confusing if I'm looking at that. So again, what I like doing is one step at a time is go ahead and bust out and draw over here. x minus 3 plus 3i. I would use my table, and you're gonna have to use this a lot if you decide to use this table. And then you're gonna have x minus 3 minus 3i. And then you're gonna have all that multiplication to do. And so again, this right here is just gonna give you this piece right here once you simplify it. And then you're gonna need another one for, let's change the color here. I'm gonna let you do this. X minus 5i. I could do this one. X plus 5i. You make your little table here. Multiply. All right, so you get x squared, 5xi, or ix, negative 5xi, ix, doesn't matter the order. And then you have negative 25i squared. But remember, whenever you have I squared, all that does is changes the sign. So this becomes positive 25. So you end up, these cancel, and you're left with x squared plus 25. And that's where this comes. And then now this multiplication is much easier. You could use this method again than these with all the i's. Then it's not that hard. It just takes time, right? So you just gotta practice. If you want me to finish this off, this is just x squared, negative 3x, negative 3xi. You got negative 3x. You got 9. You got 9i. You got 3xi. You got negative 9i. And then you have negative 9i squared. But notice, this and this, they cancel. This guy and this guy, they cancel. This is going to be negative 6x. This is going to turn into a positive 9 right here because of that I squared. So 9 and 9 will be 18. So you got x squared, and I think I'm missing one. Let me just make sure. Nope, 8. So 9 and 9, 18. You got negative 6x, and then you have x squared. So again, that's where this comes from. All right. So again, just get your practice in. Everything's the same, nothing changes. Just a lot of multiplying. So have a lot of scratch work ready, but it's not that crazy. All right, Matthew. So again, start early in homework 19. Hopefully this helps.